In this video, we'll talk about what we do with quadratics that have a leading coefficient greater than 1. And just to explain kind of what that means, before we had x squared plus bx plus c equal to 0. Now what we're going to have is we're going to have ax squared plus bx plus c equal to 0. And you'll see that the coefficient here is now a number. Before there wasn't one because it was 1. Now there is one, and you'll see that in our example problems that we do. So let's go ahead and begin with our first example. So we've got 2n squared minus 13n minus 7 equals 0. And the first thing I do is I check for greatest common factors. Did 2n squared, 13n, and 7 have anything in common? 2, 13, 7? No. N squared, n, nothing? No. This does not have a greatest common factor. So at this point, I'm going to go ahead and factor, and I'm going to use a graphic organizer to help me factor this. So I know that if I divide by a on my terms, I multiply by AC, and I add to b, that this particular setup is going to help me get to the factors that I need. So this is A, this is B, this is C off of our formula. So I'm going to remake this graphic organizer, except that I'm now dividing by 2 each time. I'm trying to add up to negative 13, and I'm trying to multiply to 2 times negative 7, which is negative 14. What multiplies to negative 14 and adds to negative 13? Well, that's going to be negative 14 and positive 1. So I can see that this term here is going to simplify. That will simplify to 7. So I've got x plus 1/2, and I have x minus 7. When I set this equal to 0, I can solve by setting each of these factors equal to 0. So what makes x plus 1/2 0? Negative 1/2 plus 1/2 is 0. So I know that negative 1/2 works.
Emily.
Then I can set x minus 7 equal to 0, and 7 is the value that makes this true. So now I know when I have my solution set that it's going to be smallest number first, which is negative 1/2, then 7, and I'm done. Let's do another example. Here I have 14x squared plus 49 plus 21 equals 0. So I'm doing this example right here, number 4. And the first thing I can see is that it does have a greatest common factor. So the greatest common factor for this particular equation is 7. So if I pull a 7 out, I'm left with 2 here, 2x squared, 7 here, plus 7x, and 21 here. Sorry, 21 divided by 7 is 3, and 3 at the end. And that's going to be equal to 0. Now I can factor this. And again, the way that I factor it with my graphic organizer is I say I need to add to b, which is 7. I'm going to divide by a, which is 2. And I'm going to multiply to a times c. 2 times 3 is 6. What numbers multiply to 6 and add to 7? 6 and 1. So I have my factors. I know it's going to be x plus 1/2. And it's going to be x plus 6 divided by 2, which is 3. And that is equal to 0, but I don't have space for that. So I'll go ahead and write each factor. X plus 1/2 needs to be equal to 0. So that's going to be negative 1/2 plus 1/2 makes that true. So negative 1/2 will be one of my factors. And then I have x plus 3 is equal to 0. Well, negative 3 plus 3 makes this true. So negative 3 is another one of my factors. Sorry, one of my solutions. And again, negative 3 is the smallest. It goes first. Then I have negative 1/2. and those are my factors. Let's do one more just to kind of get you used to what we're doing here. So the next one that we're going to do is this 30n squared right here. So I'm looking for a factor. Do they have any factors in common? Well, I know that 6 goes in here, and 6 also goes into 54. That's 9 times 6. Does 6 go into 110? Well, yeah, it goes in here 1 time. There's 4 left. It goes into 48 18 times, so it does. So I'm going to go ahead and write the greatest common factor here is going to be 6. And I'm going to have 5n squared left minus 18n plus 9. And that needs to be equal to 0. So I go ahead and I say, with my graphic organizer, I need this to add up to negative 18. I need it to be divided by 5. And I need it to multiply to 5 times 9, which is 45. So what multiplies to 45, adds to negative 18, I'm going to go ahead and factor 45. So I know that I've got 1 and 45. 2 doesn't go in. 3 and 15. Oh, hey, look, that's 18 right there. 3 plus 15 is 18. So I can place a 3 here. Needs to be negative. I can place a 15 here. It also needs to be negative. Negative 3 plus negative 15 is negative 18. If I multiply the two negatives, I get a positive 45. So that works. I can write my factors. I have x minus 3/5, and I have x minus 15 divided by 5 is 3. That equals 0. I can take each factor and set it equal to 0, and I get 3/5 minus 3/5 equals 0. That makes that one true. And then I have, for x minus 3, I have 3 minus 3 equal to 0 makes that true. So I can see that 3/5 is going to be one of my solutions, and so is 3. I write the smallest one first, which is 3/5. And then I write the larger one, which is 3. There's 3 examples of kind of how we're going to attack these problems. Really, you look for a greatest common factor. If there is one, take it out and set up the graphic organizer. If there isn't one, just jump straight into setting up the graphic organizer. Again, you're adding to that second term. You're adding to b. You're multiplying times whatever you get when you multiply a times c. And then you're dividing by a. You're dividing by a here and here. So again, these are just the main ideas for what you're going to be doing in each section of the graphic organizer. Dividing by a, adding to b, multiplying to a times c. Good luck.